Hello everyone, and welcome to the second video in the patterns and sequences unit. This video today that we're going to look at is taking a wee look at the second bullet point here, that we can determine the nth term formula to find any term in a given sequence. Right? So this nth term formula is what we're going to be looking at today. Okay, so I've got a little starter activity for you. What I want you to do is pause the video and take a wee look at this sequence 2, 5, 8 and 11 and answer the three questions A, B and C. I want you to find me the 5th and 6th terms in the sequence, find me the 10th term in the sequence, and find me the 50th term in the sequence. So pause the video just now, give that a go. Right, so hopefully if you've paused the video and you've got some answers to parts A, B and C, I'll run through these fairly quickly for you just now. Let's find the 5th and 6th terms in the sequence. Well, 2, 5, 8, 11, they're the first four terms, so the next term is the 5th one. What you can see is that this sequence is going up in threes, adding 3 each time. So 11 add 3 is 14, 14 add 3 is 17. Job done. Find the 10th term in the sequence. Well, this is now starting to sort of get a little bit trickier. What we've got up to now is the 6th term in the sequence. So the 7th, 8th, 9th and 10th terms in the sequence can just be followed on. 20, 23, 26 and 29. Right. Now, find the 50th term in the sequence. Well, I wonder how many of you got an answer to that. The correct answer is 1, 4, 9, by the way. Right. If you got that, well done. Some of the common, when I do this sort of activity in class, some of the common wrong things people try and do is say, well, hang on, I've got the 10th term. The 10th term is 29, and so the 50th term must just be 5 times 29. So 145, job done. Well, it's not. It's not as simple as that. These sorts of sequences aren't proportionate like that. So, for instance, notice you can see that in this sequence that we've got written here on the screen, that the 10th term of 29 is not double the 5th term of 14. It doesn't work like that. So we can't use proportion, if you like, to get us round the sequence. It doesn't work. So that won't have worked. I suspect some of you may have given up in sort of trying to work it out, but another thing, the only really surefire way you'd have maybe got to 149 is if you'd actually went and written out all 50 terms. So the first 10 takes you to 29, the 11th term would be 29 add 3, 32, and so on. You might have done it like that, and if you did that, that's probably the easiest way for you to get 149. This lesson is all about using a formula, and that's called the nth term formula, to help us work out any number in the sequence, any number at all. So to help us work out the 50th term nice and easily. And what it does is, the difference between the nth term formula and the next term rule, which is what you did in the last lesson, well, where the next term rule gives you how to get between terms, that only works if you know the term before it. So for instance, I would only, using my add 3 rule, I could only get the 50th term if I knew that the 49th term was 146, for instance. And that's the only way that would work. The nth term formula rule treats, if you like, these as input numbers and output numbers. Right? So the first input number of 1 produces an output of 2. The second input number of 2 produces an output of 5. And what the nth term formula does is instead of going across the terms 2, 5, 8, 11, it connects the input number and the output number together with a rule. And that's useful because instead of having to go and work out all 50 terms, well, if I knew the input was 50, then I would have a formula that would give me the output of 149. And so today's lesson is all about how to work out what that formula is. Okay, so let's have a look at how we do that. So I've got the same sequence here, 2, 5, 8, 11, 14, 17. Right? Same sequence. And what we're going to do by the end of the example is we're going to have worked out what the nth term formula is. We'll fill it in that box. So, how do we do this? Well, every nth term formula has two parts. Now, the first part is the multiplier. Okay? And that multiplier is nice and easy to spot. All your multiplier is what your sequence is going up in. And the reason for that is because if we're going up in threes consistently, then we need a number sequence that goes up in threes. And the number sequence that goes up in threes is the 3 times table. So we need the 3 times table to be our multiplier. Right? So what that means is that the first part, I'll write down a wee note for the multiplier. Look at what the sequence is going up in. And use that as the multiplier. Okay, so our sequence is going up in threes, and so what that means is that we are having 3 times n, right? 3 times whatever the input number is. Okay, so as a wee reminder, n is just the input number. So the multiplier is what our sequence is going up in. We're going up in threes, 3n. The next part, second stage, is the correction term. Now, what the correction term does is it adjusts the times table being used. Right? So it adjusts the times table sequence being used. Right? So the times table we're using is 3. And the 3 times table is 3, 6, 9, 12, 15, 18, 21, and so on. But those numbers aren't in my sequence. 3, 6, 9, 12, 15, and 18, they're not in my sequence. My sequence is 2, 5, 8, 11, 14, and 17. So if you think about the first term in the sequence is 2, and the first term in the 3 times table is 3, so we need to get from 3 back to 2. So my correction term has to be to subtract 1, so that I get 2 when I use the first input of 1. And that is our nth term formula. Right, that's it, done. 3n take away 1. And what I'm going to do is prove to you now that that works. So for the 6th term in the sequence, right, we would say n is equal to 6. Right, 6th term in the sequence will make n equal to 6. Well, let's apply the formula to that. So 3n take away 1 would be 3 times 6, which is 18, take away 1 gives us 17. 17 is what's in the sequence. So it works. Let me show you as well that it works for the 50th term. Remember on the last page I told you the 50th term is 149? So for the 50th term, n would be equal to 50. And so 3n take away 1 would be 3 times 50, take away 1, 150, take away 1, 149. So the nth term formula is made up of a multiplier and a correction term. The multiplier is just what your sequence is going up in, and the correction term adjusts the times table sequence being used, and it would be an add or a subtract. Okay, let's have another look. I've got a couple more examples to do here that will do a little bit quicker. Right, I wanted to do the first example there in a lot of detail, but we'll do this one a little bit quicker. Okay, so all we need to do is work out what our sequence is going up in for the multiplier and the correction term, what we're going to add or subtract. So let's have a look at this sequence. This sequence is 3, 5, 7, 9, 11, 13. Multiplier then. What's this sequence going up in? Well, we're adding 2 each time. So if we're adding 2 each time, then I need the 2 times table, so my multiplier is 2n. Remember, n's the input number. Okay. Now, 3, 5, 7, 9, 11, and 13, how is that in comparison to my multiplier sequence? Well, the 2 times table goes 2, 4, 6, and 8. This sequence is going 3, 5, 7, and 9. So this is one above the 2 times table, if you like. The first term is 3. The first term in the 2 times table is only 2, so we need to add 1. And that's it. Nth term formula. Right? And again, just to prove that it works, that these are no flukes, we'll do it for the 6th term, where n would be equal to 6. So 2n plus 1 will give you 2 times 6 plus 1. So 12 plus 1 is 13. That's what we have. Okay? Multiplier and correction number. Right. Last example. Find the missing terms this time and state the nth term formula for the sequence. Right. So we've got 2 terms missing. The 5th and the 6th terms. My outputs, my sequence is going 6, 10, 14, and 18. So this sequence is going up in 4s. Fair enough. Right, well, if we're going up in 4s, 18 add 4 will be 22, 22 add 4 will be 26. That's fine. But what about our nth term rule? Well, we already know we're going up in 4s, so it's 4n. The 4 times table starts at 4. My sequence starts at 6. So I have to add 2. Easy as that. Right? So you're looking for a correction term and a multiplier. Now, with this video, I've put a little worksheet. Can you complete the worksheet, filling in the tables? The tables are exactly the same as what you've seen in this video. Fill in the blanks in the table, the missing terms, and the nth term formula. Complete the worksheet, submit it back to us. Let us know how you got on.